Can you hear me? Hello? Hello, can you hear me? Can you hear me? Hello, can you hear me? Hello? Yes. Okay, good. Good, good. Okay, thank you. Okay. We're starting in a minute now. Okay. Good, good, good. All right, so let's get started. All right, good evening, everybody. This is Shiblu Ahmad. I think you guys already know me. We have an important topic to cover this evening. Of course, we are working. We are getting into IT. People work in the IT. One of the important topics in today's software development is the message broker. Why it is important, what we do in the industry today, what we are doing before. Walaikum salam. Good, 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 good. Okay, so what is actually happening? The message broker is something a computer server. That server takes message and send the message. That's what it does. Again, a, a bunch of computer server takes messages and send the messages. So why it is important? So what it used to do? So in today's development, in software development, what is happening is it's called the event driven development. What exactly means? Things has to happen right to the second, or things has to happen right to the millisecond. It means it cannot be delayed, it cannot be late, right away. That's called the digital process means things has to be done right now. So a client is requesting something, a server responds back. Okay, so message broker does this very well. But the challenge is, if the way the microservice is being developed, um, sending and receiving message is challenging. It means if we have the 10 microservice, a microservice is nothing but a small application, and what it does, a series of business requirements or a specific feature that we build, we write the code, we have the own database, and that become an application. And you can simply call this is a microservice. So in a larger projects, before, that's like the gigantic, the code base means million of line of code. That's the before, like 1990s, even 2000. Today that's not the case. Today is every system is every the big application, they will do the module by module. Module by module means, it's an example. If we do an example today is like internet connectivity, right? Comcast. Comcast have a 50 million users. Okay, understand this very carefully. Comcast has 50 million users all about the US, all over the US. And the commitment from the Comcast is things has to happen right away. Means when the from the backend from the server send a signal to the router, means your internet will run. Or when server send a message to your TV, the TV has to run. Or TV can boot, means TV can start, or TV can stop, or you can get a like the movie on the TV, or you can pay on the TV. So basically you can do everything on the TV, and thus in the server side it is happening, means the two people is communicating. Think about this. Hey, I need this, and say, okay, you got it. What is the credit card number? 123, and they say, okay, I got it. So that's the real two people is communicating. Think about the million of people is talking to the server. The 50 million users, 50 million subscriber of Comcast. They are sending the request to the Comcast like the customer service. I need the service. My internet is not working. My TV is not working. My modem is not working. My modem is slow. My router is slow. My internet is very slow. My modem is getting hit, and my IP is getting dropped. My internet is getting dropped. 50 million of people is calling to the people is crazy, right? Because if Comcast hire, think about that. Comcast hire 5,000 customer service. Think about that, and 50 million people is calling to the Comcast. Think about the complexity, right? 5,000 people cannot handle this. So it will create the nasty customer service for the Comcast. That's the scenario. But you and I do know Comcast has 50 million users. They use the Comcast internet, modem, TV, and everything else. And they need the service right away. Again, not only that it can cause the issues, but also service need to go right to the point. So that's the human connectivity, how human work. Now come to the technology. So in the technology, again, bring to the two things. One is the computer server, one is the customer, your modem. The Comcast give you the modem. So now think about this. That you have a 50 million router, means 50 million customer, and sending the message to the server, 50 million. Again, message is different. Internet is garbage, the router is slow, as I just mentioned. So now, this server is not the one server. There is a lots of server behind the scene. Why? That's a good question. One server is only responsible for the billing. Another server is only responsible 50 megabit per second. One server is only responsible for TV. One server, I'm just giving you an example. One server of the service only responsible for the TV and internet. One service is responsible for the TV, internet, and phone line. Another server is responsible for the business. Another server is responsible for the corporation. Another server is responsible for the business to business. It means Comcast has a business with AT&T. Comcast has a business with Verizon. So that's another server. It's not done yet. Some server is responsible only for the credit bureau. What does it mean? If you do not pay the bills, remember, if you do not pay the bills, Comcast will report to the credit bureau like the credit code, then your credit will be screwed up. So again, that's another server. Another server is validating your SSN when you apply online. Another server is checking your credit. So you see this? So in the server side, in the company side, there is a server after server after server, because all this server is providing the service to the 50 million people. And these 50 million people, somebody is paying $50, somebody is paying $90, somebody is paying $100, somebody is paying thousands of dollars to who? To Comcast. And Comcast is selling what? $1 billion business. So now you understand what business does, what they do. So a server has a lots of service behind the scene. So now you understand the message. The amount of message customer can send to the server is amazing because the issues. So how this is solving the today? Message broker is a software, special software that take the message from one the I'm the message broker at this moment. I take the message from the customer, and I got the message and I send the message to the Comcast. Think about that. A message broker is like a real estate broker. In the IT, a message broker is a real estate broker. Two people, one people is selling, one people is buying. Okay. So when seller sell the house, seller go to the message broker. When buyer buy the house, they go to the message broker. Again, message broker has a specialty to handle both people. So a 50 million user is continuously sending the request. They never know anything in the Comcast system at all. All they know, message broker. Again, nothing you see visually. Everything is logical. All the things we are talking is a logical, the computer system communication process. You don't see anything. You all see the mobile app. In my mobile app, I'm just turning on the app or doing something. It's good. But it's logically the software development team build this kind of system to digitalize the company's process, and that's become the software, and that become the application, and that become the service. So again, message broker is a specific tools that capable to handle and taking the message from one person and sending to the another person. In the company end, they have a lots of systems. We call them application. Walaikum salam, the Rizal Bhai. From the customer side, remember, all they know, just send the request. I need this, I need this, I need this, I need this, I need this. From the broker side, broker just get them. As a broker, I'm the broker. I just take the message, 50 million message. Now think about me as a broker. I have to be powerful. What? I have to be powerful to handle the 50 million people, right? So in the message broker, I need myself, I need a 50, I need myself like a 2,000 people like me. 2,000 Shiblu, that will be the message broker, and that is called the cluster. A cluster is nothing but a group of computer equal to the cluster. What they do, because they just take again 50 million, the request is coming to the broker. Broker means like a lots of computer. They just take the message and they send to the message to the right people, means right to the Comcast. So now the message broker is like you got to understand the message broker. Who is the message broker? They are a software. It's a software you install in the operating system. In this case, it's Ubuntu, or it is the Red Hat, or it is you can call the another like the Unix. Again, enterprise company never ever use Windows. Windows is dead. Okay, so forget about the Windows. So a message broker is a software that install on the operating system, which in this case is Linux operating system, which is open source. And the two service, again, a consumer, which is the Comcast 50 million user, a provider, which in this case Comcast itself. Okay, so Comcast, all the services, as I said, all the application, they connected with the broker as me, and all the consumer as a 50 million consumer also connected with the broker as me. So now you see this, even though the I'm asking the service to the Comcast server, we don't know each other. They don't know each other. This is called the decoupling. Decoupling means even though they are getting the service and the receiving the service and the providing service, but they don't know each other. They know the as a broker as me. Through the broker, they get the service or they provide the service. So now what is the event now? So remember, as I said, as a 50 million user, as a Comcast, you guys know the horrible customer service of the Comcast, right? I do not want to bash them out, but let's talk about the more. So in the human service is absurd not to have the we call bad things. In the technology, things has to happen right away. It called the event. It's simply called the event. Means the moment I paid Comcast billing, I'm expecting in 30 seconds my internet need to be up. You see? That's it. It's called the event. The moment I paid my internet billing, the broker got it, and broker sent to the who? Sent to the billing system or the Comcast, and Comcast billing, look at the Comcast billing is a specific server where the billing, all the code is there. Comcast billing receive my what? Receive my what? Receive my bill and come back to the broker as me. And then what broker did, broker went to the another service where the internet need to be restart for the consumer because consumer just paid the bill. So broker right away said, or they said, hey, this guy just paid the bill, activate his internet, right? Everything is happening. Because why? You just created an event, which is event is this: I paid the bills and the broker got it. Broker forward the message to the biller, the Comcast billing system, and billing reviewed my the credit card information, accepted my bills, and then billing just said to the internet system, internet provider means the Comcast internet system, hey, this guy just paid the bills, turn on his internet. Look at this. Everything is, that's a human communication, and system is doing it. Both system is doing, and the internet system told the broker, hey, internet need to be on for this guy, and the broker just send a message to your modem. Broker send a message to your modem, the hey, internet need to be on. In 30 seconds you will see your internet is up and running. So that's the communication process. So you see how the human need to communicate, like how we are doing it in the computer system. Communication is the similar, but as you just heard, in the 50 million user request cannot handle by the 5,000 the Comcast, like the customer service, it is impossible. Plus people need to sleep, people need to eat, people need to enjoy the life, people need to remember everything, people have their life, people cannot do any of this. This is where come the automation. A message broker is a special software, is called the broker. It take the message from the consumer, and the consumer is me, like all the clients of the consumer. In this case, again, consumer is the clients, and the publisher or the producer, which is the all the Comcast service means the billing, internet, and the modem and the router and all this. That the service means all the small application. So now, because of the things has to happen right to the point, because things has to happen fast, that's where come to the events means the previously back in 90s, remember, if you apply for something, it takes 14 days, right? Remember that? You go to the bank, you do something, and after 5 days you bank open an account. In today, it is not the case. You type your information, it look for your credit report, and it tells you congratulations, or it tells you I'm sorry, you are declined. You see this? So you are communicating. It's like the chatting with the two people logically is happening, and you get the approval right to the point. This is called the digital process. So it's called the event-based communication. In the modern software development, we develop all the modern application that has to communicate in the both side right away. Second, millisecond. Communication has to be millisecond. So that's where I come to the message broker. Testing message broker is important. So let's go where we use the message broker. Let's go back. Any question? Let's see. Okay. Uh, I hope there is no question for now. If you guys have any question, you can ask. So let's go back to the scenario. Where did the message broker get used? How the company is solving the problem. Think about the vehicle industry. Okay, we just talk about the Comcast. Yes, Comcast or the Spectrum, they're the real solution because they have a 50 million users and they have a like 100 millions device. Okay, 100 millions device means 100 million customer, and they have to provide all the services, or the Comcast will do all the services. So to communicate, to provide the service effectively, efficiently, right to the point, and it's called the SLA. It's called the service level agreement, which is a company is responsible to provide the service 95% of the time to the consumer, means their clients. In this case, if you are not able to, many times, remember, if you call the Comcast, hey, for last 3 days my internet is not working, most of the time the customer service will tell you, I'm going to refund you, or I'm going to give you $15. Do you know why? Because there is a service level agreement, or there is a good customer service, then you need to give them back money back. And think about this, in the computer system, that there is no case like this, right? Computer system, you just request, response need to happen. So industry, every industry you see today, they're providing the service right away. Thus they do this, they do things through the message broker. The trading industry, message broker. The online ticketing, message broker. Online booking, message broker. Uber, message broker. Lyft, message broker. Flight, message broker. Then what? Vehicle industry, message broker. Autonomous, do you know the autonomous means? Autonomous means the vehicle will be driving itself in the street, you don't need to touch anything. Autonomous, message broker. Or sending the message to the device and receiving by IoT. We're going to the IoT. So we just mention all these things. Again, we just mention all this, the use cases, the industry, they all they provide the services to their clients, and the implementation is, the best implementation is message broker. So message broker is just providing the services, and they just decouple to the two people. One is consumer, one is the producer. Okay, consumer can be the client. In this case, I'm just giving an example. Consumer means it's like the Comcast clients, but consumer can be an other application. Okay, in this case, actually consumer is the client application, and the producer is also the application, means they're producing. So now think about how the industry is changing. So for the, if you are part of the software development team, and they produce the application for their business, and if the application is like this, like a application is complex, and that they are providing the service to the customer, or they have internal like 100 of system, they need to communicate with one another. Again, remember, in the Comcast, they have 100 of system, hundreds of server. You can call the service. Make sure you can, whatever you call. A service is like a logical piece of the computer code that can go to the virtual server, or that can go to the bare metal, like the physical server. Where the server is code, the code is stored, that's called the server. That's providing the service to the consumer, means the client. Like when you type the www.yahoo.com, actually it is go to their server. Okay, so now why the things are moving, why nowadays we do things very efficiently, very effectively? Because the message broker, it's a lightweight, it has the power. Okay, it has the power to take the message and provide the message. And the message broker is a series of computer, means you let's say if you have a 50 million user, you need, maybe you need like a 2000 server. 2000 server means 2000 broker. In the all this 2000 server, it is called a cluster. A cluster is nothing but a group of computer doing the same thing. Same thing means providing the servers in a they are just load balancing. They're just providing the services to the customer, so the customer can get the service. So that's called the cluster. So today we actually need this kind of, we do like if you are in the QA industry, you are busy with the GUI and the automation. Actually, things are different. If you work in the, unless if you work in the old company, old application, old web application, it's okay. It's okay means they still use the what? They still use the old application, does not need any of this. The newer application which create the event and get response back from the events right away, they implement the message broker so the customer can get the service and the business can booming like the blast. They're like some people were selling the loan, like the business was 100 million. Nowadays they yearly sell like the 8 billion. Make sense? Because of the you are providing the service to the your customer faster. So let's go back. So who does what? Okay, in this category, the a DevOps engineer is responsible for the whole infrastructure. Means installing all the server, installing the message broker, in this case Kafka, Mosquito, and the provide the connection details to the software developer. In this case, software developer can be the Node.js, Python, Java, and whoever. And they write the application for who? For the customer, because the customer in this case is a Comcast. Comcast business provide them business requirements. And then software developer start writing the code. So they write the code, and then as a QA, they start testing. So in this case, if you want to do the testing, the message broker, you need to come up with the mindset, come out your mindset that, well, this is not the GUI testing. Even though the end product can be the web application or the mobile application. However, the immediate testing or the business is driving this application through the message broker. So your majority testing start involving with the message broker. To do the message broker testing, there is a series of tools in the industry. There is some free tools, there is some paid tools, there is some coding involved, so you can use them. However, since this is not the GUI testing, you need to verify in the backend. In this case, many companies, many companies, they implement the modern software development. They actually go to the cloud. Now you say, wow. So cloud means a company has everything ready for you, means all the server ready for you. You just pay them and you get the server, you deploy your code, you're ready to go. So that's the reason Amazon Cloud, Google Cloud, the Microsoft Cloud, they are the provider. So you do not need to invest like the 50 million or 100 million to implement your the code. You can literally implement by $5,000, even less than that, and you start dumping your code. Means you start producing your code and your code will go live, your customer is ready. So you see this, your event base came because you need the robust customer need to be supported right to the point. You heard the microservices. Microservice is nothing but instead of developing the gigantic like the code base, like the million line of code, you actually break down to the small piece, and those small and the microservice, they internally connected with one another. So they internally connect with one another. That's also called the message broker. The application internally connect with one another. That's also through the message broker. Why? Message broker is a special software that the send and receive message to the people. It's called the publisher and the subscriber. As somebody need it, somebody gives it. Somebody takes it, somebody provide it. So again, that's also message broker. Message broker is not like only the customer and in this case, anybody takes some information from you, they're your client and you are providing. So in this case, you as a testing point of views, you need to testing the message broker. So you need to understand the message broker actually send the smallest message. So why it is powerful? You guys heard me. I said so many times, RESTful API is driving the industry. That's correct. That is correct. However, RESTful API is not designed to handle or to like the request. They just request response. They don't do anything else. They do not do the work the way it does the message broker. Okay. Message broker is lightweight. RESTful API is the HTTP protocol. It works on the HTTP protocol. It's itself HTTP protocol itself is a fat. Fat means thick protocol, means they need their own a lot of information before take your information. Means you are sending this piece of information, but you are getting a big, like a 2 pound of the package, right? So that's the RESTful API. Message broker solve that problem. They just, you are sending this message, message broker send you this message. That's it. Again, RESTful API, it is working perfectly when two server is communicating. However, the RESTful API is not designed the way the message broker is designed. Example, you may not understand, but I'm giving an example. As we just said, microservice is developed based on the small team. 6 or 7 people develop one microservice, means small application, and that small application has link another application. That application has link another application. That application has link another application. Think about it. There is a hundreds of application equal to that major the business area, and that 100 application your microservice, they need to internally communicate with one another without just saying, hey, update, my application is updated, can you update your application? Hey, my application is updated, can you update your application? This you can do it, right? Not effective, right? Because you're serving the customer. Think about that. Message broker solve the problem, because the moment you update one application, it knows, other application knows something just happened. Okay, something just happened, so they can update efficiently and effectively. Message broker can do that. Message broker like works seamlessly and doing all the work for you behind the scene to provide you a service. You don't need to worry about it. It's like you can implement the RESTful API to integrate the microservices, but it is not the right solution for a 50 million or 100 million customer base platform. So that's where the message broker. However, now, so you see this, you have a GUI involved, you have a mobile involved, you have an API involved. Now you come to the message broker testing involved. So you see, so nowadays, who become the test engineer? The moment you go to the job, you're thinking, wow, damn things, I just learned the GUI automation. What is my damn job? You don't have a damn job, because if you go to the application and it is completely event-based application and they're building the modern application, you are really a not a suitable guy for that project for a longer period of time, because you don't know any of this. You just learned the Selenium. Good. But if you learn the message broker thing, like how the system to system communicate, how the microservice internally communicate, you are good. Because at the end of the day, everything is GUI, but GUI is the last result of the application, means the last piece a company worried nowadays. Because everything happen, we do, everything we build nowadays, everything in the backend. Microservices, RESTful API, message broker, everything in the backend. Company ensure that my backend is very solid, very stable, very strong. And then those the things you did in the backend, those are consumed. Consumed means those are like you are like putting a cables. Just putting a cables to your mobile application, right? When you hit a button, when you tap on a mobile application, actually it's coming to the coming to the wearing. It's called the RESTful API through the HTTP protocol, and come to the backend and say, hey, I need this, and it give the service. And from the RESTful API, it goes to the another one. It's called now it goes to the message broker. From the message broker, it goes to the backend service. It's called the ecosystem, right? It's a complex nowadays. Think about the Alexa. Think about the Google. They're the complex system, but actually they're all following the similar development pattern, which is the event-based development. Means my customer need to get the service right away. I need to provide the service as much as possible, as fast as possible. So the backend development is completely complex. We use all the modern tools and technology to build the backend, and then once my backend is strong, my front end can ready to provide the service. That's the reason if you become a QA nowadays, you need to get prepared with the message broker, the API. Of course, the database query is part of your testing, and then you do your mobile testing, and you do your web testing. Actually, everything is the similar thing based on the same application, but the testing approach is different. The testing and the strategy is different. Testing timing is different. Remember, the moment the application is started to develop, at this moment you have to do the message broker, then it can go to the RESTful API, and the third category, it will be the your web application, means the GUI website testing. So if you are learning from wherever you are, you just need to open up your brain. Now, how the come to the electric vehicle industry now. How the message broker is getting used there. The whole world is moving and transforming to the electric vehicle. Think about this. Think about by 2040, you can think or imagine that over 100 million vehicle, maybe less, maybe more, 100 million vehicle will be converted, or will be new architecture that will be completely electric vehicle. Now think about that. Within these 20 years, is it possible for companies to train up all the technicians they can deal all the electric vehicle, fix the electric vehicle problem? By human is ineffective, it is impossible, it is inaccurate, it will be risky to develop the human way, like training the human to do this. That's the bottom line. That's the like a simple, like a human thinking. Machine will solve that. Yeah, machine will solve that. How? Okay, so think about the Volkswagen they sold China 30 million vehicle in 2021, and all the electric vehicle, and they have a 20,000 dealership across the China, and they all are capable to take any type of the vehicle from the Volkswagen and fix them, Volkswagen vehicle. However, they do not have the electric vehicle technician. Let me tell you what is the electric vehicle. Electric vehicle is the bunch of the ECU will be developed, the architecture will be different. They completely work with electric vehicle, means you just plug in your electric vehicle to the plug-in station, your vehicle will be charged, no gas needed. If the full electric, no gas needed. So you see the electric will provide your vehicle, so you don't need to gas. If the semi-electric, so it means you have an electric charge, also you have a gas. In this case, you can do either way. That's the today's scenario is electric vehicles and the gas. So you can use the gas and the electric, full not electric. So now if in the 30 million vehicle, if the 10 million vehicle or the in 20,000 the dealership, if they receive 100,000 vehicle today in the dealership, they do not have the manpower to fix all these vehicle. Or let's say they have a manpower, but this manpower do not have the electric vehicle knowledge yet to solve all the electric vehicle. So at this moment, as a company, as a group of company, it is a risk. So what they're doing, I'm controlling everything from the back end. What does it mean? All the ECU information will be in the back end. Everything, what the ECU does, how to restart, how to reset, how to the update, and how to flash, how to verify, everything. Which model year this one will use, which version it will be using, everything in the back end they are holding. And they're servicing, they're developing all the services. And then they put it all, the whole platform on the cloud. And so why? Why in the cloud? Think about that big company. The Volkswagen has a customer in Germany, Volkswagen has a customer in America. Volkswagen has a customer in China. If you put in the cloud, it's easy because for the American customer, it will go to the from the American server, means American North American region. For China, it will go to the from the China cloud. For Europe, it will go from the Europe cloud. So now you see the distributed model. So regardless of wherever you put the vehicle, the the moment the vehicle is connected, the backend system will know where this vehicle is located, and based on that, the right away it start the automation process. Okay, the 2015 model, 2019 model year. This is the Audi. This is the electric vehicle, and this is the all the CCU. They will start poking all the ECU, make sure how the ECU is working, and the system find out, wow, ECU number 538 is the problem. What is the problem? Then they will run another mechanism. Again, everything is happening. You went to the dealership, dealer just put the cable in your car, and they hit the button, everything is happening from the back end. When the technician is clicking, and the system is doing everything for you. Eventually, system even resetting resetting your ECU. ECU means electronics, like a circuit unit. Resetting your ECU, updating your ECU, fixing your ECU on the fly. Because at this moment, there is no other way that the 40 million electric vehicle can be solved by the human mechanism within the short period of time, and human cannot remember all of this computer technology. So computer will be memorizing everything for you. You just become an operator. You become an operator, just how to use, how to plug in the vehicle, it will be solved. And the whole thing is doing in the backend is through the message broker. And everything is decentralized. Decentralized means distributed model. It is through the cloud. So each cloud region will be responsible for their own area of the customer. So that's where is the vehicle. Now think about the other way. Think about the other way. You have a 40 million vehicles is driving in the industry, and they're driving in the road, right? Sometimes you say, Alexa, I want to go to the Starbucks, right? You say that, right? Yeah. So Alexa tell you, well, here the Starbucks, go to the right, go to the left, Starbucks is here. So do you wonder how that happened? Do you know what it's doing? It's called the connected vehicle. Means your vehicle is connected to the back end. Yeah, that's right. So vehicle has a device. That device you can call the display, and that display has a modem, that can have a router, that can have a LAN. Everything is internal. You don't see anything. And that device has all the application. Application means the software. Those software connect with your backend. Yeah, it does. So when you do from the mobile app, you say, Alexa, what is my daughter is driving now? Right? You say to your mobile app, and Alexa says, oh, your daughter is in the club now. Okay, you see this? Because Alexa is in a vehicle, and your daughter is in the club. And as a parent, you say to the Alexa, Alexa, where is my daughter now? And Alexa says, your daughter is in the club. How? Because Alexa has a map. Alexa knows in the map. So Alexa is a different service, map is a different service, right? And you can say, well, Alexa, lock the vehicle now. Or you can call your daughter, right? Hey, what are you doing in the club now? That's how you control. That's how you control. That's the one scenario. Let's say you went to the big stadium, right? You enjoy the game, and the parking like the 1 mile away or the half mile away, and you have no clue. 50,000 people in this stadium. You're watching the game. Your butt is cold, so now you need to start your car, right? You can do that from the mobile app. You say that, hey, start my car. It will. Alexa, start my car. Alexa will start your car, right? So your car will be heated up. That's the one scenario. Another is you can say, Alexa, where is my car? Alexa will tell you, you want to go to your car? Yeah. So go straight, right, walk left, here is your car. See that? That's everything is happening. It's called the connected vehicle, right? That's not done yet. Now, you know that when you become a good driver, you get the bonus. Do you know how that happened? Again, a device. Device is working. Your device is connected with the backend. So what you are driving, it is sending the report to the to the provider. Means your insurance company. Insurance company. Oh, this guy is driving 50 miles when it is 30 miles. So it knows. That's not done yet. Even from the backend, from the server, like the from your, like I said, like the GM, they're sending the message to the vehicle. Why? Because they need to update all the software in your vehicle. They need to be updated. Okay, there is two types of update in each vehicle happen. One is called the firmware, which is like the hardware software. One is called the software. Software means, as I just said, Alexa, where is my car? Alexa, I want to go to Starbucks. Alexa, find out my vehicle. Those called the software. And the firmware means your hardware software need to be updated as well. So from the provider, from your backend, you send the request to the vehicle and you start updating the software. So in this architecture, if you think about that, what happened? In this architecture, your vehicle has a modem, and your vehicle need to be software, need to be the develop, and they need to be connected. They connect with the message broker, and the message broker and send the message to the backend system, and backend system is coming talking back and forth and send to the message to your vehicle. Again, vehicle means the user. Sometimes is the user, sometimes is a vehicle itself. Everything you see, everything is called the modern software development. The whole complexity is called the ecosystem, right? Human cannot do any of this, nothing, right? Now more complex. You keep hearing, wow, the autonomous vehicle is coming. Do you know the challenge? There is tremendous amount of challenge. One of the challenges, internet. Because if you want to get the fully autonomous, you have to have the excellent internet that's coming to the 5G. What 5G will do, when you drive, the vehicle will have all the sensor. All the sensor will be in the vehicle. Okay, if you want to go to the fully autonomous vehicle, will have all the sensor. They will just do the mechanism, like censoring everything else behind around them and the driving, right? And then it will be like making the decision on the fly. Okay, challenge. If your internet get dropped, sensor may be static. Sensor become the static because you are not getting the data from the backend. The backend is not walking you through. And that's the one of the challenge for the autonomous. It is the challenge. Weather is another challenge. A big city is another challenge. So there is tremendous amount of challenges coming for the autonomous, but autonomous is coming, and that will solve the big cities. Your Uber, you Lyft, there will not much anymore Uber and Lyft, because they want to make sure the technology can drive the business. In this case, Uber driver will not be needed. The vehicle will be driving itself, and then it will call. It will call from the, once it reach out the destination, it will call, hey Shibla, I'm here. It's like the human, right? Hey, I am here. I don't see you. Just look at me. It will tell you everything, because that's the solve the problem. So because human is too costly. Human is expensive. Human does not do the things right away. Machine does very good. So now you need to know how to build the human, how to build those technology. That's become the software development team. And you do this kind of thing, your job will be stable, your career will be sustainable, you will be happy and healthy. Cloud computing will be one of the best for the future. That's seriously, that's true. So Shiab said yes. So because of all this complexity will be handled by the cloud computing. Cloud computing means the group of people, the rich people like the Jeff Bezos, the Amazon owner. He has like a 20 or 30 or 50 data center across the globe, and his data center is managed by his own, the engineer, all the system engineer, and all the system is ready for us. They build all the services behind the scene for us. As the small company, big company, the mid-sized company, everybody go to the Amazon cloud and they just open the system, they just provision the server and they start installing the services and service is ready. Behind the scene, you don't need to maintain those server if you don't want to. You do not need to worry about the internet connectivity. You do not need to worry about the database connectivity. You do not need to worry about the building cost. You do not need to worry about nothing. You just worry about the building the code, develop the code, deploy the code, the product is ready, your customer is seeing the service. That's the reason every job you go, they say, do you know the cloud? Do you know the cloud? It means all the existing data center is not going to be destroyed, but it is not going to be updated. What it means, company will be continuously building more and more application. I just said why, because more and more process will be digitalized. So the cloud will be more like I would say 100 times efficient than the typical data center, because cloud is they have a power, they have a dedicated people, they use the modern software, they use the modern application, they use the modern framework, they do everything behind the scene. It's just ready to go for anybody who is building the application. So you work in the industry, make sure you know the cloud is nothing but is ready-made, like the hotel, everything is there. Your company is building, writing the code, deploying on their cloud computing, and you do everything else. You'll be asked to know the microservices, you'll be asked to know the Docker, you'll be asked to know the Kubernetes, you'll be asked to know the CI/CD pipeline. Those are called the modern software development, because they're all based on the event-driven development. It means you need to provide the service as fast as possible. Fast means millisecond, less than millisecond, and the cloud will be driving the force for that. So that's how everything will be in the future. And message broker is driving the industry. Whenever it comes to the microservice need to be communicated with one another, or the publisher and subscriber, the consumer and the publisher need to be communicating. That is all about the message broker. Okay, so this is all I wanted to cover this evening. And the software is, let me share my screen quickly. I think I did something. Let's see. So I actually did so what message broker does, again, this is in a nutshell, it's a producer which actually produce all the, so again, this is the discussion I normally can discuss. When one application is sending the message to the other application, think about this. This is one application. This is one application sending the message to the another application. Think about both is the application. So in the middle, he does not know him at all. Okay, all he knows the broker. Broker means the message broker. So he sent the message to the broker, and broker sent the message to the consumer. That's what it does, because that has the power. This broker is like a bunch of computer. Like if you have a 10,000 requests, maybe you need the 50 computer. All the 50 computer is called the cluster. This cluster is called the whole thing is called the message broker. Message broker is spatial software just sending and receiving the message. Become a broker just to provide the service to the producer and the consumer. Is good. Is really good. So as a client, any publisher or subscriber that connects to the centralized broker over a network is considered to be the client. Again, as I said, everything is logical. It's not the human. I gave an example how the human communicate, but in the computer system, everything is a software, means everything is logically happen. So it is important to note that there are server and the client in MQTT. Okay, I will tell about the MQTT is both the publisher and subscriber are called as a client since they connect to the centralized service. Clients can be persistent or the transient. Persistent client maintain the session with the broker, means they continuously know regardless of what. The persistent client continue connected with the broker regardless of what. Okay, and transient client are not tracked by the broker. And for the software developer, they get all this client to implement to develop the software for them. Broker, again, the broker is the software. Again, this all the software, as I said, that receive all the messages from the publishing clients and send them to the subscriber clients. It holds the connection to the persistent clients. Since the broker can become the bottleneck or result in a single point of failure, it is open clustered. Look at this. It is open called the clustered for scalability and reliability. Remember, as I said, if 50,000 people send a message to Shiblu, Shiblu will be dead. So there will be like the 100 Shiblu, means 100 Shiblu's clone need to be get the request from the 50,000 people, and then they provide the service. And thus the 100 Shiblus will be called the cluster. Why? Because you need the scalability and you need to be reliability. So that's the reason it's called the cluster. It is up to the implementers to decide how to create a scalable broker layer. Again, this is not the QA job. This is the software engineer job and the DevOps engineer's job. There is a message broker, the Kafka, Mosquito. They have a specific engineer. They do all the work. Nothing with the QA job. But the QA needs to know how the publisher and subscriber work based on the business requirement. QA has to know how to test it. QA has to know how to connect to the backend. QA has to know how to connect to the front end. So QA job is all the testing based on the requirements. But whenever it comes to the broker, you don't see any UI. Everything has to be in the backend. Can be the Linux operating system, can be specific Mosquito client, means specific software. Do this. Look at the HiveMQ, this AWS IoT, like the Alexa. Look, they are all the broker. They provide all the services. And the topic is an MQTT. Again, I will go over MQTT pretty soon. MQTT is the endpoint to the client to connect. Again, the endpoint is a specific like the direction where the client means the producer can be the client, publisher can be client, consumer can be client. So, and the endpoint that the client can connect. It acts the central distribution hub for the publishing and subscribing messages. In typical MOM, machine to machine, okay? Machine to, it's called the MOM means machine over machine to machine. A topic is created before the publisher and subscriber connect to the endpoint. Again, MQTT is a lightweight protocol that is used in the many industry, like the vehicle industry, any embedded device industry, like the vehicle, the Comcast, and the Spectrum, AT&T. They all use the MQTT protocol because HTTP REST as a thick protocol because fat. HTTP REST is a protocol that needs a lot of data, and that's not healthy to use when you need to access your customer like in nowhere. Like you're driving a car in like 100 miles from the city at this moment. If you have an MQTT protocol, because it's a lightweight, it sends the data faster. If you have a HTTP REST protocol, it misses the data, it disconnects the data over and over. So MQTT protocol is established by the IBM developer because they went to a nowhere in United States and they find out, wow, connection is not working. At this moment, MQTT protocol is developed. It is basically very lightweight. It sends a small message between the publisher and the subscriber. So again, this is the things is you need to know more details about this. Mostly it is needed for the software developer, not the QA. Connection. MQTT can be utilized by clients based TCP/IP. Again, TCP/IP is the transmission control protocol, internet protocol. Again, TCP/IP means are you going to buy the bus or the train or the plane? IP means you're like the internet, like your numbering, like a specific address for you, so you can reach out to the specific location. Again, this is the connection details is talking about this, and that's about the whole thing. So let me go back to this and let's go back to the StreamYard. Okay. So that's the total 1 hour session. I wanted to say thank you guys for joining. I wanted to just mention if you're learning to become the developer or the QA or the DevOps, make sure you know the industry that is way different than it was before. The development approach is changes, microservice architecture, the event-driven the development, and then the cloud computing, way like a more popular nowadays than your old application. Old application means as a QA you do the GUI testing. Those are not the case anymore. Again, thank you very much, guys. Have a wonderful night. We'll talk the next week with a different topic. Have a good night. Thank you.